Hi everyone. It's been a while. I wanted to follow up on my airplane video. It was actually the first video that I made was a military exercise for the jets, but the thing was that I needed to show people a little bit more about the instruments, so I made the first one that was about 34 minutes long. Now, if you've watched that video before watching this, you're probably a little bit familiar with the instruments now, but again, I will go over them, and that was about the gyro compass and the altimeter that maintain the airplane level with the ground. And this is also, again, known as the artificial horizon. Now, one of the things that I want to bring up is the fact that the military exercises that are used in the Air Force, of course, is actually for below radar and stealth detection. There is quite a few ways that they practice this, and I'm going to demonstrate this in the video right here. This is going to be a F-18 Super Hornet. It's called the Blue Eagles Air Show. They are actually pretty professional daredevils of the sky, and they do some amazing barrel rolls and some low altitude stunts. And this is actually called a low pass flyby. And like I said, these are also exercises that are practiced by military in order to go below radar at about 100 foot above the sea level or on land. And from what you see there is that the plane is actually about a good 30 to 40 feet off of the ground, because the dimensions of the Super Hornet is about 60 feet in length. To do the below radar training on the sea or on land, they actually fly about 100 feet or maybe a little lower, and they do it continuously to go over the surface of the land or the water. And in order to do that, they do it for very many miles. I mean, they can go upwards from 50 miles to 200 miles. They actually do this for about an hour or 30 minutes, and they do this with training on land or sea. The military aircraft with no autopilot is usually how it's done, and it's for about 30 minutes above the ocean's surface at 100-foot altitude for 30 minutes at 400 miles an hour. Now, at 400 miles an hour, that's 60 minutes. That's going to be 6.66 miles per minute. Now, 30 minutes at 6.66 miles per minute is about 199.8 miles traveled in a straight line. And they do not curve down for any curvature. If the ball is actually, like the Earth's radius at 3,959 miles, the pilot would have traveled 199.8 miles with about 319,000 inches of curvature below them in just 30 minutes if they didn't nose down for the curve. Water is always level. The planes actually go against free fall acceleration, so they're able to go against the free fall acceleration and do what they want. When they're traveling in this straight line in 30 minutes at those inches, when you convert them by 12, that's 26,613 feet. Or you can convert that to miles, that's going to be 5.05 miles above the ocean. And if they do not nosedive down, they're going to be 5 miles above the ocean. Again, right here I put the equation. It's going to be 198 miles on a spherical Earth with a radius of 3959 miles radius is the miles squared times 8, the inches divided by 12, which is 26,613 feet, plus the 100 feet that they were already maintaining. So it's going to be 26,700 foot of curvature drop in just 30 minutes if they don't compensate for the curve. And basically it's 5 miles above sea level if they don't nose down. And I want to show that also, again, with AutoCAD of 3959 miles. Zoom out because it's pretty big. And again, this is AutoCAD and uses 15-digit precision. It's AutoCAD Civil 2016. If you're not familiar with this program, it's an architectural program. It's very precise, and it is the best, and it's the best for quite a few reasons. Now I'm going to do a convert 100 miles to, 100 feet to miles, sorry about that, which is 0.01893. That represents 100 feet above the surface on a spherical Earth. So, and right now we're going to go 200 miles, and I'm going to get a dimension here. If they travel at a straight line, like planes do because of the gyro compass, it's the artificial horizon, so that keeps the plane level. It moves with the plane. If you haven't watched my video, I'll link it below. And I'm going to take a linear dimension of the curvature drop. And if you see there, it comes out to about 5.074 miles. And I'll do another dimension here for the distance, so you can all see that in fact it is 200 miles. Now remember that I rounded this up to 200 miles, and the diagram that I made was at 199.8, but it's just about the same, 5.04, and this one is at 5.07. Now, anyone can put this to the test. The math is correct, and the comments will be available on the bottom. As usual, people can comment. If you have any friends in military that know about this stuff, they can confirm it. And please, keep the comments civil. I guess this is it for now, and I will talk to you all later. Thanks.